Hi, my name is Matthew Kowalczyk of Ocean Floor Geophysics, and very happy to be part of the Blue Innovation Symposium this year. I'm going to speak specifically to our integrated cathodic protection inspection system. This is a non-contact system mounted on AUVs, where we very successfully deployed this on commercial projects in deep water for pipeline inspection. I'd also like to say that part of this presentation and my hope from this Blue Innovation Symposium is that we're able to meet some partners and collaborators with whom we can develop new applications for the system on other subsea vehicles and for other applications like cable integrity inspection, again from an AUV, active towfish, ROV, fault finding, a subsea structure inspection in other markets where we're not active, such as wind farm and tidal power. The motivation for our development of the AUV-ICP system is pretty obvious. It's to replace the extremely slow and inefficient cathodic protection inspection that's currently done by ROV. This led us to apply our expertise in marine electromagnetics and magnetics to developing a system that could be deployed on our survey AUV. We own and operate a 3,000 meter rated Hugin, and we also help operate a 3,000 meter rated survey AUV over in Japan. So we developed the system to fly at survey speeds, 3 or 4 knots, right down the pipeline, altitudes 5 to 8 meters off with extremely high sensitivity and very accurate positioning relative to the pipeline. By flying down the pipeline and very accurately measuring the electric field in three dimensions, as well as the magnetic field, integrating that with pipe tracking, precision navigation, seawater conductivity, you're able to measure the electric fields very, very accurately, and from that estimate a cathodic current. And of course, this cathodic current output from the anodes has been the missing link in actually doing complete pipeline inspections. As you see, and this is why we call it the integrated cathodic protection. You can now combine that with SAS data, still photos, laser scanners, multi-beam imagery, all of this information combined at the same time, along with your cathodic currents, allows you to get a complete picture of the pipeline integrity. Because of our background in operations, it was really important not to inhibit or limit the regular operations of the AUV. So as you can see, our final implementation has what we call these limpets, and that really is the entire installation on the outside. And as you can see, it doesn't really change the operations of the AUV itself, which is really important in terms of efficiency, safe operating conditions, and the ability to deploy these systems in the field. In addition to being operationally efficient, the system is extremely accurate and repeatable, and this has been proven by us not only in the original demonstrations back in 2018 in the North Sea, but in commercial operations since then, where we've been flying up and down the pipeline multiple times to demonstrate and prove to ourselves the repeatability, and ultimately to our clients, of course. So I thought I'd just put up kind of from the pipeline world, the type of products we're delivering with this. As you can see, this is data acquired all in a single pass of multi-beam. There's actually synthetic aperture sonar card at this same time, digital imagery, and this line over the top here is actually the electric field, and you can see there's a bump every single time as we go over the anodes, from which we calculate the current output of those individual anodes. And so I've just kind of put up cartoons here of different ways that what these look like, on a typical pipeline where there's no problems. What that cathodic current outputs look like as you move towards a current where the structure is draining. So not only does it give you the ability to look at individual outputs from the individual anodes, but because you can cover 100 kilometers in a day, it gives you the ability to get a snapshot of the overall cathodic health of the pipelines also. And to then go and identify individual problems such as passivated or disconnected anodes, as well as damage and which occur as current sinks on the pipelines. Having these being able to calculate the cathodic output allows you to see if there is a problem when you're doing these snapshots year after year, these pipeline surveys, to identify if there are problems, problem areas, anodes being consumed too quickly, and the overall health of the pipeline itself. As I said right at the beginning of the presentation, we're really interested in expanding the applications for this commercially proven deployed system for other applications. So if you have some ideas, please reach out to me. We're always we play well with others, and we're always interested in learning about new problems and hopefully being able to provide a solution or part of a solution along with you. Thank you for your time.